This is a tiny, self-propelling wooden robot made of one single material, and it may just transform the face of the planet. Literally. Place it on the ground and it will slowly start to bury itself. Attach a seed to it and it could be used to replant forests all over the world. It's a groundbreaking, ingenious design that may also play a huge role in energy harvesting, soft robotics, and sustainable buildings. But what exactly is it? Its development was initially inspired by hygromorphs, structures that change shape in response to humidity, like pine cones, whose scales automatically close when they get wet. Plants often use these kinds of structures to change and modify themselves in response to the environment. In fact, there's something super similar to this wooden robot already found in nature, the erodium plant. It produces fruit and seeds with a hygromorphic tail-like structure that helps propel it into the ground to germinate. As the moisture in the environment changes, it coils and uncoils in an attempt to drill the seed further. And while this plant was a major inspiration for this research, there was one major problem. The success rate of erodium seeds for drilling into the ground is actually really low. On some terrains, it even has a 0% success rate. So to improve upon nature's design, the research team decided to create a more efficient hygromorphic structure.
Based on our calculation and simulation results, having 3 anchor points prevents it from flipping over or falling down, so that it always faces downwards at a very specific angle. So that helps with the success rate a lot, actually 5-fold in our experimental results. The coil numbers are sort of simulated with mechanical simulation, so that the trade-off is that having more coils will soften the entire structure, but having a little number of coils will not have enough thrust force and the actuation effect.
The drilling allows the seed to be placed safely underground, where there's a lower chance of being eaten by an animal, affected by fire or temperatures, or simply washed away. This entire endeavor was a huge feat of science and engineering, with the attempt to engineer wood that had the ability to curve extensively while also remaining strong and stiff. Trials were run for the optimal number of coils, angle of entry, curvature of the wood. Truly, there's a ton of math and precision that went into designing this. When the design comes in contact with moisture, the wood expands, but the inner layer cells do so at a faster speed than the outer layer, causing the robot to coil. When it later dries, it contracts at different speeds again, with the inner layer cells shrinking more quickly, pushing the seed further into the soil.
We chose oak wood because it's one of the strongest wood that's also accessible. We had this series of chemical processing, which is almost the same process as making paper. We've done experiments on the processing to make sure that the wood is pliable at the point, but not as easy to break as a prolonged processing would cause. Then we can introduce mechanical molding to have this intricate structure.
And it's the first of its kind to be made out of one single material, not requiring anything synthetic. The benefit of using only wood, it's completely biodegradable, so you're not left with a bunch of waste sitting on the forest floor forever. On top of everything, it's able to carry seeds up to 75 milligrams in weight, compared to typical hygromorphic seed tails in nature, which typically only carry around 8 to 20 milligrams of weight, opening the potential for different types of reforestation. And because of the customizability of the design, the team's able to tailor them to different terrains. They also tested dropping the seeds from drones in the air, and they were able to maintain a 90% success rate for the optimized angle. Not only that, but the research team was able to add symbiotic species on the robot, including beneficial fungi and nematodes, increasing plant health and the overall survival rates in natural environments. But beyond simply planting more trees, the long-term implications are really fascinating. While there's been a huge amount of interest around soft robots, we actually made a video covering some new liquid robots, these wood robots don't quite fit that category. They sort of blend both soft and hard robots into a new firm category. Firm robots have the advantage of being able to interact with their environment, like soil, more easily, while also having some of the shape-shifting qualities of soft robots that are so amazing.
It's one type of energy into another, which is water absorption in our case into a drilling motion. It can be in other forms. There is heat-responsive material, and that converts into other motions, maybe circular, maybe linear, actuator. Just a random example, you can have a window covered in this sort of actuator, and once it's raining, you can have some scales that opening and closing according to the humidity outside. So the design is passive. Once it's made, we just rely on natural resources.
It's an amazing example of bio-inspired engineering, looking to solve problems with a little help from nature. Thanks so much for watching. I hope you found that as fascinating as I do. If you did, make sure you like the video and subscribe for more science in the coming weeks. We'll see you soon. Peace.